All right, guys, here we are, our second video of the year. We're on section 0.2, simplifying review. So I'm going to go through a few questions here with you. You're going to take the opportunity either in class, on our remote Wednesdays, Zoom activity periods to ask questions if you need it. And we'll get some good practice time, hopefully, when we're together next time. Okay, so we're going to be simplifying some things today. So I know sometimes when you're simplifying, you don't always know, like, am I done yet? Should I keep going further? Should I keep looking for things? Really our goal today, just to play around, manipulate some of these expressions, and I'm going to show you a couple little things as we go. All right, so number one, this was a note on the very first page of our notes for this packet, or I guess the first page where there was actually notes being taken. When I look at this first expression, and I say expression because there's no equal sign, so that's going to become very important for a couple problems right now. I see that there's a bunch of mixed terms here. There's radical terms, there's rational exponents, there's radical terms again. So that's ugly. A really nice, easy thing to do to make these all look the same is to turn them all into exponents. So the cube root of x is the same thing as x to the 1/3. All right, so multiplying and combining, I don't like that fraction bar. I'm going to do that. Multiplying, dividing, these types of radicals, it's usually a lot easier to turn them into exponent form. So this is to the 2/3 power. So now we're a little easier to work this way. So we talked about this. I mentioned this last video. If you don't remember how to do something, go back to basics. So I will ask you all now in your head to answer, what is x to the second times x to the third? We know we have to add the powers. So that becomes x to the 5th. So that's all we're going to do in the problem we're working on here. We're going to add the exponents. So that becomes x to the 12/3, and that becomes x to the 3/3, which we know simplifies very nicely. And that becomes x to the 4th minus x to the 1st. And that's pretty good. Now, if you wanted to keep going, we see we could factor out this GCF here. I'm not going to worry about that now. We'd be left with x to the 3rd minus 1. And hopefully little alarm bells are going off in the back of your head. That is a difference of cubes. So we could go back and look at our formula from the first page and continue factoring that using the difference of cubes formula. All right, for the sake of time, I'm not going to worry about that right now. Okay, so if you need to pause, rewind, rewatch, that's what these videos are for. Slow me down if you need to. Number two, we have division of two rational expressions. All right, so we have these fractions to deal with. First thing, I know we see this division sign, and we probably go back to 3rd grade, and we say in our heads, keep, change, flip. Hopefully your last couple years of teachers have drilled that out of you. We're going to use some more mathematical terms this year. So instead of saying keep, change, flip, you guys probably know what I'm going to say. We are going to say multiply by the reciprocal. All right, that's a little nicer way to say it. So I'm going to let you guys run with this one. I think I'm going to pause my video, and you guys can start working on this one on your own. So I guess the first thing, we're just going to take the reciprocal of that last term. And you guys can factor this first one out, and we can start dividing out common terms, and I want to see where you get with that. So you guys can work on your own for a minute. When you unpause, or I'm going to pause, you should pause. When you're done with it, unpause, and then see how you did. All right, so here we are. We factored. We notice now that these terms, the x plus 4s, can divide out. Really, anything divided by itself is always 1. So that's what's happening. They're not really canceling, but they're dividing out and becoming a 1. And hopefully you also notice this nice strategy from years past. This 1 minus x can really be turned into a negative x minus 1. So your teachers have probably told you in the past when you have these sort of things show up. So if you have like a 1 minus x over x minus 1, those divide out and turn into a negative 1. So the same thing happens here. This 1 minus x, x minus 1, those divide out and turn into a negative 1. And now we're done. We have this x plus 3 left in the numerator. We have that negative out front. Well, I guess not out front, but being multiplied by it. over x plus 2. So that's a great answer. If you wanted to distribute that negative through the numerator, you're good. You could also distribute it to the denominator. You could also just throw it out front. Any of those are fine, but there's a nice simple answer for us. Okay? Next. Number 3, adding and subtracting rational terms. So like I mentioned on question 1, there is no equal sign here. This is just an expression. So what we can't do, I can't just say, oh, let's multiply everything by x minus 4 and x plus 6. Because that would unbalance this expression. That would be like, I'm just going to multiply it by 20. Things will change. That changes the value of this expression. All right, because this is just a number, really. It's just a hidden number in here. If I were to multiply that number by 20, it would be a completely new number. But what you can do is multiply anything you want by 1, right? That's the identity multiplication. If I multiply that by 1, I'm not changing it. Another way to write 1 is like, whatever, 50 over 50. So if I multiply this second fraction by 50 over 50, I'm not changing it. I'm making the numerator grow the same amount as the denominator. So we're going to use that to our advantage. We're going to get a common denominator. But in order to get that common denominator, I can't change my fraction. I can't just tack on an x minus 4 down here. I have to multiply this whole fraction by 1. And I'm just going to write 1 in a very careful way. So to get a common denominator, I know this term has to have an x minus 4 tacked onto it. And I know my first term has to have an x plus 6 tacked onto it. So I'm going to multiply my first term by 1. But I'm not just going to write it as 1, I'm going to write it as x plus 6 over x plus 6. So here, hopefully you guys can go on your own from here. I'm going to pause and show my work again. So I want you guys to pause your video, try this one out, and when you're ready, you can unpause and see how you did. Okay, so there you have it. So take a look at your work, see if there's any places that are giving you trouble. One thing to be really careful of is after you multiply through you're combining your fractions here. Once you multiply through by this x minus 4, this negative sign needs to carry through. So it's not just 3x minus 12, it's negative 3x plus 12. That negative 3 carries through both of those terms. So that's where I got those two values from. So be really careful there. At that point, I combine like terms, and it kind of feels like I should be able to go further, but in that case, I just can't. So it is what it is. We're done. There's your nice final answer. All right, let's go down to, well, we'll do number 4 first. We'll do number 4. All right, so I'm going to show you a strategy here that's going to be very helpful throughout the year. It's a little more to do than ways you may have seen a question like this in the past, but it's much more efficient. I guess that didn't sound right. It's more efficient. There's more thinking to do, I guess, but it's a lot nicer. It's a lot more streamlined of a process. So we have a complex fraction here. We have fractions within fractions. So here's my big kind of fraction bar, but in the numerator we have fractions, and then in the denominator we have fractions. So what you've probably seen in the past is to just treat this like two different problems and look at the common denominator. So what your teachers have probably shown you is you want to get a common denominator. You want to combine those terms in the numerator by getting a common denominator, just like I did on number 3. So for example, and I should have said, don't write this because I want to show you another way. We multiply this by x over x. We multiply this by x plus 1 over x plus 1. And we get that common denominator. We combine like terms, and we get one nice fraction, something over something here. And then we do the same thing in the denominator. We want to get another common denominator. So I would multiply everything by x over x, and that would give me another nice fraction. But the goal is to get the denominator of each part of your fraction the same, which they would then divide out. I'm going to show you another way to do this. And it's very similar. The math is the same. It just kind of takes a step out of it. So what I'm going to do for this complex fraction is to just skip that middleman, and I'm just going to look at my 3 denominators, and I want to think about what my lowest common denominator is. So in these terms, I have x's, I have x plus 1s. So my lowest common denominator is x times x plus 1. All right, notice it's not x plus 1 twice. It's not 2 of those. All I need to do is basically the bare bones to cover all my bases. I have one x plus 1 term. It just happens in 2 spots. So my lowest common denominator is just x plus 1. All right, so what I'm going to do is use that LCD and multiply this fraction by some value of 1. Like I said before, we can't just multiply by one thing. We have to multiply by something over something. So what I'm going to do is multiply the numerator and denominator by my LCD. So I'm going to multiply everything in the numerator by this and everything in the denominator also by that same thing, right? Because when I'm multiplying by 1, I'm not changing it. So watch what happens. It's the same thing that would have been done the way I just showed you, but it's a lot quicker. So these are 2 terms, so I have to really distribute this to both of those terms in the numerator, and I have to distribute this whole term into the term in the denominator. So hopefully that's kind of where the trick to this is. So if I multiply 2 over x plus 1 times x plus 1, those x plus 1 terms divide out. So I'm going to show you right here, that term here divides out with this. So what I'm left with is 2 times x. So my very top left term, really what I'm doing is multiplying this by that whole x plus 1 LCD. So once I have that taken care of, now I'm going to multiply my second term, the negative 1 over x, also by, can I get that? Oh, it's all connected. Oh well. I'm going to multiply the second term also by this x plus 1 common denominator. So now when I multiply this by my term, the x's divide out, and I'm still left with the minus 1 times the x plus 1, right? Remember that x plus 1 divided out here, it didn't divide out in this one. All right, so I'm distributing it. I guess another way to write it, I'm multiplying every one of these terms by x plus 1. So maybe I should have written it that way. So this x plus 1 divided out there. So that's how I was left with the 2x. Here, the x is divided out. So that's why I was left with the 1 times the x plus 1. So maybe I'll show that with let me erase that a little bit. So hopefully that makes sense what I did. Every single term is getting multiplied by this LCD. So now in the denominator, hopefully this will kind of bring it all home. In the denominator, I'm multiplying this term here by my LCD, by the x plus 1. All that happens is those x plus 1s divide out. So I'm just left with the leftovers, 3 times x. Okay? So there's a bunch of these on the worksheet that we're going to practice in class, or if you're at home, we'll continue to work at these, but it's a really helpful strategy, especially when we get later in the year into some more complicated complex fractions. But now we're just going to combine like terms. So I have 2x minus x minus 1 over 3x. We combine a little bit of like terms. We're left with x minus 1 over 3x. Nothing else can divide out. All right, don't fall into that trap of crossing the x's out. No, 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 no. All right, they have to be complete like terms for that to happen. So there's my final answer. Okay, so again, I multiplied, there's 3 terms here. The 2 over x plus 1, the minus 1 over x, and the 3 over x plus 1. I multiplied each of those terms individually by the same thing, right? And like we talked about, if you multiply everything by the same thing, it doesn't change it. It doesn't unbalance your equation. So multiplying every one of those terms by the same thing, I divided out the common terms, and I kept what was left. So that's how I got to my final answer there. So that's one to put a star next to. Watch it again if you feel like you need to, but we'll work on that in class. Those are questions that tend to give people a little bit of trouble. So if you're having trouble with that, talk to your learning group, talk to me, come into a Zoom, and we'll get it done. We'll figure it out. All right, last thing to look at is when we have a radical term in the denominator. So basic, if we had like 3 over radical 2, our goal is to get that radical out of the denominator. So what we would do is multiply the numerator and the denominator by radical 2 over radical 2, by basically whatever the radical term is there. So we would be left with 3 times radical 2 over radical 4, which is just 2. So that's how we would rationalize if there was just a single term in the denominator. Now, if there's a binomial down there, get out of here. All right, if there's a binomial, So like 1 minus radical 3. To rationalize that, we need to multiply by the conjugate. So what we're really doing here is creating our own difference of two perfect squares. So if 1 minus radical 3 is in the denominator, we need to multiply by 1 plus radical 3 in order to rationalize it. So we're left with the radical 6 times 1 is radical 6. Radical 6 times radical 3 is radical 18. We can, simplify that in a second. Now in the denominator, we multiply, we do our double distributing, whatever you call it. But the great thing is the two terms with the radical 3's in it divide or cancel out. So we have 1 times 1, we have 1 times radical 3, we have negative 1 times radical 3, and then we have radical 3 times radical 3, which is 9. So we get a minus 3 there. And now we can simplify. So radical 6 plus radical 18, careful, is not radical 24. Radical 18, excuse me, simplifies down to 9 times 2, which we can call 3 radical 2. 1 minus 3 is negative 2. And we're done. Ooh, excuse me. Okay, so I think it's as far as we can go. No need to do anything else. We can't do anything else. So there's your video. All right, let me know if you have questions. Complete your online homework check that goes with this, and I will see you guys in class. Good job. Bye.